All right, this is an introduction to the experiment 7, Newton's second law of the Atwood machine. This is a very, very good experiment. I wish we were able to do it on the in the lab, but I found a simulation that I think is pretty good. I like it because there is some variability, so that you are going to get a bit of an error. So most of the others simulations that I found either didn't have find enough increments. You know, you had to increment by hundreds of grams. This one you can increment by 10 grams. I'm sorry, by 5 grams, and so you can get a little more resolution. So let's begin by just talking about Newton's second law. Force equals mass times acceleration. If we look at it from the acceleration point of view, we can, let's just, if you solve for acceleration, you get acceleration equals force divided by mass. So what does that mean? Well, if you increase the force, whenever you have an equation like this, that something equals the ratio of something else, if it's in the numerator, if you increase what's in the numerator, this side will automatically increase. They're directly proportional, and force acceleration is directly proportional to the mass. If you increase this, it's inversely proportional. If you increase the mass, the acceleration will go down, and vice versa. If you decrease the force, the acceleration decreases. And if you, in the inverse relationship, if you decrease the mass, the acceleration increases. If you lower the mass, the acceleration will increase. And that's what we're gonna study in this particular experiment. It's going to be a virtual machine, but it'll still work, and I think you'll have fun doing this experiment. Now let's go through the lab report. Okay, if you go to experiment 7, they're going to have an initial GL. I forget what the GL stands for. But the experimental planning, that's optional. You can see the big bright letters. That's optional. You're welcome to do it. I don't know that it adds anything to the experiment, but we're going to start, of course, with the advanced study assignment. You need to turn in your advanced study assignment. Read the questions. All of the questions can be answered by reading the lab report. So I want you to read the lab report completely. So you answer the advanced study questions. There's some CI advanced study questions. Now, normally I tell you to ignore those, but I'm gonna give these as extra credit because you will be able to answer these based on the experiment that we're doing, the virtual experiment, because it is kind of based on a computer instructed laboratory. So let's go on and discuss some of the things. So basically what we're doing, if we look at this section here, experiment 7 examines Newton's second law using the Adword machine by TI procedures and/or CI procedures. Both procedures apply the second law by varying the total mass while keeping the unbalanced force constant. That's going to be the first part, data table 1. And then secondly, varying the unbalanced force while keeping the total mass constant. We're going to be transferring mass from an ascending mass to a descending mass. Okay, now let's go back. Read the introduction and the objectives. This is what an Atwood machine looks like. This is kind of the one that we use in the lab. So it looks something like this. It's not mounted to a wall. This is kind of the one that they use in the virtual lab. So it's going to look something like that. But basically, you have a descending mass. A mass that's going down, and you have a mass that's going up. And we're going to use the acceleration of that of those two weights, those two masses, to calculate the acceleration. Okay, we're going to use the velocity of those masses to calculate the acceleration. Okay, now we don't have, well, we're not using the equipment, it's all virtual, but we can't do it. We can use 5 gram increments. We can't do 2 and 1 gram increments. But I want you to read the theory. Let's see. There's the advanced study assignment number 4. There's the answer to it. We're not going to do anything that measuring the friction or the mass of the pulley. We're going to ignore those, and you'll see that. You know, so whenever you see like the mass of friction or the mass equivalent, we're going to ignore those because it is a virtual lab. And so anywhere where you see, ignore the columns. Right here it says ignore the columns headed with asterisks and the mass equivalent and the mass friction symbols. So as we go along, I've blocked out, anything that has an A or a B, like 2A or 2B or something like that, if it has an A or a B, you can ignore those. We're not doing those portions of the experiment. So you can see like the 1B and the 2B, 3B, and 4B, I've scratched those out. So let's see, I think that star is from the doing it in the lab. Now, I've replaced the data. If you look at your data table, it doesn't have this distance of travel, and it also has the mass 1 and mass 2 reversed because I had in this particular virtual lab, they make the mass 1 descending automatic, the mass 1 descending. In your lab, mass 2 was descending. So I've changed it around a bit. Plus you have, the distance isn't always the same. So I've added this section here where you have to measure the distance each time. And this is where you're going to start with like 60 grams and 50 grams and measure your data. Then you're going to add 50 to each, so you'll get 110 grams and 100 grams. And then you'll go to the next increment, 160 grams, 150 grams. And then finally, the last one, since we can't go over 200, you're going to do 200 and 190. So that's, so there we're keeping, there's always a 10 gram difference between the descending mass and the ascending mass. And so that 10 grams, that is our force. The 10 grams times the gravitational acceleration, that's our force. And it's constant throughout, but the mass is increasing. We're keeping the force constant, but the mass is increasing. What should happen to the acceleration? Figure it out. Okay, on the next one, we're going to keep the mass constant, but we're going to change the force. So there's always going to be, I believe it's 390 grams, in both, the combined masses is going to be 390 grams, but we're going to be transferring masses to the other so that there's always an increase in the difference. And you should see, so we're going to be increasing the force, so you should see the acceleration increase at the same time. And I've modified this graph also. I post I said I modified this table. I said graph, I meant table. I modified the table, and I'm going to provide you with these tables. So you don't use the ones in your normal write-up. You're going to need these to do the experiment. It's kind of a crude modification, but it should work. And then you answer the questions at the end of the lab. Okay, that's the introduction to the lab. The next video I'm gonna present is how to actually perform the lab. I'm not gonna perform it with you, but I'm gonna show you how to perform it. All right, we'll stop here and get to that next video.